Okay, so when I say the word robot, what pops into your head? Probably something metal, right? All nuts and bolts? Well, today we're going to throw that whole idea out the window. We're diving into a world that's, well, it's less about gears and a lot more about jellyfish. So, here's the breakdown. On one hand, you've got your classic robot, rigid, metallic, powered by motors and gears. But then you have soft robots. These things are flexible, often made of silicone, and they take their cues straight from nature, powered by things called artificial muscles. We're talking about a massive shift here, from these clunky machines to something that moves like it's, well, like it's alive. All right, so that brings us to the big question, right? What in the world is a soft robot? I mean, what does it even mean for a machine to move like an organism? At its very core, soft robotics is all about building machines from these super flexible, compliant materials. And the goal? It's not just about being squishy for the sake of it. The real aim is to copy the incredible, amazing ways that animals and even plants move and adapt to whatever's around them. And this flexibility, it unlocks some seriously cool new abilities. Think about it. A rigid robot isn't going to squeeze under a door, but a soft one? No problem. A big metal claw would just crush a raspberry, right? But a soft gripper can pick it up so gently. And here's the big one. They can work right alongside us humans without being dangerous. You don't have to worry about a heavy metal arm swinging around. So you might be wondering, where are all these incredible designs coming from? I mean, they don't just pop up out of nowhere. Turns out, engineers are basically taking notes from the best designer in the business. Millions of years of evolution. Seriously, where they find the blueprints for a robot that can crawl through rubble or stick to a wall without any glue? Well, they look at the original experts. And this is where it gets really, really cool. Engineers aren't just copying the look of these animals, they're copying the function. They look at an octopus tentacle, which has 0 joints, and they create what are called continuum manipulators, arms that can bend and twist in literally infinite ways. Or they study a gecko's feet and figure out how they stick to walls using these tiny molecular attractions called van der Waals forces. That's what led to incredible things like NASA's gecko grippers for use in space. And then there's the snake. They mimic its crawling motion to build robots that can inch their way through super tight pipes. Okay, hold on. If these robots don't have motors and gears, how on earth do they move? This is where the whole concept gets seriously mind-bending. Just let that sink in for a second. Instead of putting an engine inside a machine, the material is the machine. The body and the muscle, they're the exact same thing. It's a complete paradigm shift. So how do you turn a material into a muscle? Well, there are a few really clever ways. The most common one is using pneumatic actuators. Just picture tiny, air-filled channels inside the silicone. You pump air in, and it bends and moves, kind of like inflating a really complex balloon. Then you've got these things called electroactive polymers. These are amazing plastics that literally change their shape when you zap them with electricity. And finally, shape memory alloys. These are special metals that you can program to remember a certain shape, and they'll snap right back to it when you heat them up. Wild, right? Okay, so we've got these robots that can move in all these cool, squishy ways, but that flexibility creates a massive problem. And honestly, it's one of the biggest challenges in the whole field. Just think about this for a sec. You know exactly where your hand is right now, even with your eyes closed, right? That's because of the joints in your arm. That sense is called proprioception. But what if your arm was a single flexible tentacle? How would your brain have any idea if it was coiled up or stretched all the way out? The solution is just brilliant. You give the robot a nervous system. Engineers created what they call e-skin by embedding these super stretchy sensors made from things like liquid metal or conductive gels right into the robot's surface. So as the robot bends and flexes, the sensors stretch right along with it, telling the main computer exactly what its body is doing in real time. And you have to understand, this field is moving at lightning speed. Get this, the newest development is something called touchless sensing. It uses a principle called the triboelectric effect. It's basically a fancy type of static electricity. With this, these new robots can sense what an object is made of before they even make contact. So they're not just getting a sense of themselves, they're developing a sense of the world around them. All right, so we've got the inspiration from nature, we've got the movement without motors, and we have the sense of touch. Now, let's put it all together and see what this incredible technology is actually doing out there in the real world. And this is where you can really see the impact. In medicine, We're talking about flexible endoscopes that can snake their way through the human body without causing damage. In farming, you've got these delicate grippers that can pick berries and tomatoes without turning them into mush. There are even fabric-based exosuits that act like an extra layer of soft muscle to help stroke survivors walk again. And get this, in the deep sea, there are jellyfish-inspired explorers that can survive the absolutely crushing pressure where a normal sub would just be flattened. So the big takeaway here is pretty clear, right? We're watching robotics evolve. We're moving away from robots as just rigid tools and toward robots as adaptive, resilient organisms that can interact with our world in a totally new way. And that really leaves us with one final big question to chew on. As that line between machine and organism keeps getting blurrier, what is that going to mean for our future and for our relationship with technology?